So as of right now, there are 25 questions total on the test. So I might throw one out and just do 12 and 12, or it might be 12 and 13, or 13 and 12 on each of the 2 days. Sort of remains to be seen. I know that sounds like a lot, but some of them will be very quick. And I mean, realistically, on the AP test, you have 45 multiple choice questions in a span of an hour and 45 minutes. So if I'm asking you to do 12 or 13 multiple choice questions in 60 minutes, that's still not even the pace at which you are expected to go on the AP test. So slowly working towards getting you into that sort of shape. That's sort of how I view the whole getting ready for the AP test. Yes, it's open note. However, with, even at that not quite AP pace, it will still be a pretty quick pace. And so if you are relying on your notes too much, you will, with some likelihood, run out of time. But yeah, that's kind of how I view the whole AP preparation is we're getting into shape. It's like a race. No, it is not all fruit response. It is all on, these are good questions. I guess these are things that I have in my brain that I haven't communicated to you. It's on the College Board website. So it will all be multiple choice. Yeah. Yeah, getting into shape for the AP test. For the next couple nights, I don't expect you to be doing any FRQs because you should be preparing for the Chapter 5 test. So we'll sort of touch base again on Thursday about what the FRQ multiple choice prep will look like over the next 10 days. Because we have spring break coming up, right? Yeah. And as much as I love having breaks be breaks for AP students, it is kind of like not a break. You guys are all, I mean, I guess you can make it a break, but then it'll just like really compress a lot of the work you have to do. Kind of personal choice there, but we'll talk about that. Tasha, was that the related rates problem? No, you will not have related rates. Christian, it'll all be mixed. It'll all be mixed in. Yeah, maybe I should just type this into the chat. 24 or 25 questions on board site. Choice. Split between Wednesday. Note, don't rely too heavily. And yeah. So let's, I guess, are there any additional questions about test format? All right, so let's take a look at the survey that I sent out, because that will sort of guide at least the start of class today, what questions we look at. Time permitting, I also want to look at, I forget what question it was. What was the question from 5.8? That was the W sub?
I think it was 20, 21.
There was a question that Mr. Smith failed to solve on Friday, and then figured it out. That will not, it will not show up on your test, but there's some chance it could show up on an AP test, and so we might go back to that. 25 from 5.8, yeah, or 5.7 maybe. But first, let's look at the results from the survey. Survey says, let's see, last minute responses. Nope. Show number 14 was a big vote getter. Number 11, 17, and 1. So tackle those 4 first and then see where we're at. Okay, let's do this. Stop this shit. The server encountered an error. Please try again. What server? What is going on? Oh, my drive server probably. That's okay. Stop share. New share, advanced. Anybody do anything awesome this weekend? No? Zoomies? Oh, what's this? I don't need this. I mean, I'm sure we all watched with delight as the UCLA Bruins continued their magical run through the NCAA basketball tournament, and then watched with equal disgust as the USC Trojans also won their game. And we all look forward with eager anticipation for SC to run into the buzzsaw called the Gonzaga Bulldogs tonight, and equally hopeful for the UCLA Bruins to take down the Michigan Wolverines. It's a tall task, to be sure, because those Michigan boys look good. Anyway, that was one of the highlights of my weekend. Having my blood pressure raised for 2 straight hours. And then just when we thought the game was won, Alabama hit that 3-pointer. It was over at the in-laws. I screamed at the TV. You kind of got to let your crazy out little by little around your in-laws. Like my wife knows I'm full crazy, but her parents are still learning over the last couple of years. So they got a glimpse on Sunday night when they didn't frickin' foul and they let the guy shoot the 3-pointer. But it ended well. Came back in overtime. I've expressed to you the utter insanity of allowing events literally completely outside of your control have any effect on your emotional well-being. And yet that's what sports are for Mr. Smith. Whether it's the Dodgers or the Lakers or UCLA, have zero control over what happens on that basketball court. And yet it will have real effect on my emotional stability. So kind of crazy. Here we go. Number 11. And I think if I'm remembering when I looked at number 11, part of the confusion could be that it was not super clear what was part of the, I think it was like a len maybe, or a cosine or something. It wasn't clear if part of it was part of the cosine or not. So here we go. Practice test number 14. Yeah, here we go. Chapter 5. Practice. Test. And number 14 was asking us to find the general solution to the differential equation dy dx is equal to the cosine of x times e to the sine of x divided by the cosine of y. So differential equation, we're separating this and seeing what happens. And luckily it is an easy separable equation. We've got our y down here, all of our x's up here. And so we will do a little cross multiplying, get that the cosine of y times dy is equal to the cosine of x times e to the sine of x dx. And now that we have clearly separated our variables, meaning we've only got y's on the left, we've only got x's on the right. We can now integrate on both sides, hopefully end up with y equals something only involving x. So the left side is real smooth because the integral of the cosine is the sine. Sure. Technically sine of y plus c. The right side is going to be a little more involved. And I think maybe part of the confusion is first realizing that this exponential part is not inside of the cosine. It is not inside of the cosine. So probably they should have written it as e to the sine of x times the cosine of x, and that could have clarified, but they didn't. So what does that mean? Well, I see this integral and I think to myself, well, chapter 5 has been dealing with derivatives and integrals of exponential functions. I'm thinking the thing that we're going to end up integrating is e to the u, or e to the something. But I see this e to the something and there's another function up here. And so this just feels u sub e to me. And anytime you're looking at an integral, there should be this process of sort of like feeling out, how are we going to do this? And it might not be obvious at the start, and you might have some false starts and some dead ends, but you should just kind of start trying stuff. And so for me, I see e to the something and think, hey, I know how to do the integral of e to the u. So let's let u equal sine of x and see what happens. Well, if u is equal to sine of x, then du is equal to the cosine of x dx, which means that dx is equal to du divided by the cosine of x. And this is already starting to feel pretty good. I see this cosine of x in the denominator. I see there's this cosine of x over here. We might be okay. So then doing these substitutions, we end up with the cosine of x times e to the u, subbing out dx for du over the cosine of x, and we get this magic moment where the cosines cancel out. We get sine of y. We're going to ditch the c for now. The c will just kind of get added on. No, we'll leave it for now. It's okay. Times the integral of e to the u du. Now this is just so much nicer. The natural exponential function has this interesting quality that it is its own derivative, which means it's also its own integral. And so we end up with the sine of y plus c is equal to e to the u plus another c. And then at this stage, because really this is like C1 and C2, we're just going to kind of morph these into a single c and say that the sine of y is equal to e to the u, but really u is the sine of x plus some generic c. And then we go to our answer choices, and we don't see that. And we're like, oh, yeah, because they probably want this as like y equals something. Right now, y is trapped in the sine function. Well, fear not. We have this thing called the inverse sine, or the arc sine, that if we hit both sides, it'll undo this regular sine, leaving us with y is equal to the inverse sine of e to the sine of x plus c. And that is one of our answer choices. I think the c lives outside. It really doesn't matter. Oh, wait, no, it does matter, indeed, because the answer is B, not A. a matter of order of operations. So the answer is arc sine of e to the sine of x plus c. That could also be tricky. Yeah, I can see that. Cool. Questions, thoughts, feelings? Okay, next one up. Let's see. Not that. Is that what I want? No, I want this. 17. Yeah, let's do it. Put that away. 17. Oh, yeah. And you will, in high likelihood, have something like this on your test. So it says if f of x is equal to the arctangent or the inverse tangent of x, then what is the limit as x approaches square root of 3 of f of x minus f of square root of 3 divided by x minus square root of 3. This appeared early on in our live, I think the chapter 1 test or chapter 2 test, probably chapter 2 test. Something quite like this. This is one of our definitions of the derivative. So this expression is f prime at radical 3. Well, what's f? It's arctan. So f prime is 1 over 1 plus x squared. And so f prime of square root of 3, plug in a square root of 3 there. That looks a lot like 1/4. This is a trick that we need to be aware of. It's not really a trick, it's just knowing the definition, a definition of the derivative. Cool. Cool. Moving on. 11. Oh yeah, 11. I remember 11. I think 11 is the one that they want us to do long division. Ew. Really? It's kind of ew, but then it's easier if we do it that way. I did try to reconcile it by not doing long division. Couldn't quite get there, so we'll see. 11 is the integral of 12x squared over 2x plus 1 dx. Now, there is, or there should be, a pathway to success that involves a u sub to get 1 over u, and then an x sub with that definition of u up here, but it gets pretty hairy pretty quick. If we have time at the end, we can kind of come back and look at that. The way that is less hairy, or at least ultimately less hairy, is to do a long division here, to actually end up with a quotient of which just one part is this rational part. So what does that look like? It looks like a side hustle. So long division off to the side. 12x squared divided by 2x plus 1. We ask ourselves, what do we multiply 2x by to get 12x squared? That'd be 6x. We then multiply that back out. 12x squared plus 6x. Subtract that. 12x squareds cancel. Get a negative 6x. What do we multiply 2x plus 1 or 2x by to get negative 6x? Be a negative 3. Multiply that back out. Negative 6x minus 3. Subtract that whole thing. Negative 6x's cancel. The subtract 3 becomes a positive 3. So when we do that division, we get 6x minus 3, remainder 3. The remainder 3 is going to be that rational part that turns into a log. Let's rewrite this then as the quotient, which is 6x minus 3 plus 3 divided by 2x plus 1. Okay, the remainder gets put over the divisor. And now this is a little bit more manageable because integral of 6x minus 3 will go real quick. And this situation is a lot nicer than this situation. This is a straight up U sub that'll work out nicely. This was kind of a nasty guy. So let's break this into its parts. Integral of 6x dx minus 3 times integral of dx plus the integral of 3 over 2x plus 1 dx. First guy turns into 3x squared. That guy turns into minus 3x. And this guy, we got to do a little work. It's, like I said, significantly less work than this one. Let's let u equal 2x plus 1. So du will be equal to 2 dx, which means that dx is equal to 1/2 du. So this is really 1/2 times the integral of 3 over u du. And actually we can just pull this 3 out as well. Let's just call this 3/2 times integral of 1 over u. Cool. Now we get 3x squared minus 3x plus 3/2. The integral of 1 over u is the natural log of the absolute value of u. Should probably throw a plus c in here somewhere. And then we need to make sure that we sub back in for u. 3x squared minus 3x plus 3/2 times the ln, the absolute value of 2x plus 1. Plus c. Plus c. Like I said, it should be possible to do. I was kind I'm doing this on scratch paper. Like a double, not a W sub, but a U sub that then turns into an X sub. But somewhere along the way, things got messy and I lost a constant or I gained a constant. But this is sort of the path that you would have to walk. And I'll just tell you it's harder. It's not as fun. Yes, identifying that you were supposed to long divide here might have caught you out, but now you know that's a possibility. We did do an example like that in our homework, but just sort of be on the lookout. And I would say particularly when you have a fraction where the numerator has a degree that's 1 higher than the denominator, you should be thinking long division, especially in this chapter. Cool. Moving right along. So that was number 11, which means number 1. Whoa. Oh yeah, number 1. Yeah. A lot of you chose A there. A lot of you chose A there. Let's see. Question 1 says function h is given by h of x is equal to x to the 5th plus 3x minus 2. And they tell you that h of 1 is equal to 2. Okay. And they want you to figure out what is the inverse of h, its derivative at 2. Okay. Now, here's like the tempting false flag answer. We have this idea that, okay, inverses, well, first of all, we need to recognize this problem is not asking us to compute the inverse of h. And in fact, I'm not sure how we would do that. Okay? It's asking us to use our knowledge of inverses and their derivatives and the reciprocal nature of them in order to find the derivative of the inverse at a specific number without even knowing what the inverse or its derivative is. Because we know what h is. And we know that h prime is equal to 5x to the 4th plus 3. And the incorrect way to do this problem would be like, oh, okay, inverses kind of, yeah, reciprocals. Okay, if I want h inverse prime of 2, and that means the reciprocal of h of prime of 2. Yeah, okay, that feels okay. Yeah. And I've got h prime. Yeah, okay, cool. 1 over 5 to the 4th plus 3. 2 to the 4th is like 16. 1 over 5 times 16 plus 3. 80. 1 over 83. Yeah. And like the AP test is like so nice to you. And 1 over 83 is an answer. Yeah. First one out of the gate, I'm feeling good. And then you look back over your score report and you miss number 1. Where did we go wrong? Right here. This is not correct. What the relationship actually is that the derivative of your inverse at some number a is equal to the reciprocal of the derivative of its inverse at the number that produces A. At the number that produces A. And so putting that together with our puzzle, if we want the derivative of H inverse at 2, we need the derivative of H at the function or at the value that gives us 2. Luckily, they tell us that. They tell us that if you plug 1 into H, you get 2. And so we need this to be 1 over H prime of 1. 1 over H prime of 1, which is a cat of an entirely different color. Plugging in 1 into the first derivative of H gives us 1 over 5 times 1 to the 4th plus 3, which is 1/8. 1/8. Yeah, a little devious, a little tricky. And so, Nate.
How come it's like B instead of A? Or why is it like that,
Because when we look at the derivative, it has to do with the way that we reflect our inverses over the line y equals x. Actually, let me outsource this to the book because there was a really nice diagram in the book when we went over this. This is in 5.2, I think, 5.1. Let's see. Oh yeah, I even wrote in the book. That was kind of mean of me. So when we look at the graph of a function, and so the first one was this cubic looking function, the derivative at 1, for example, that we looked at, is this very steep line, okay? And so the derivative at C is here. The derivative that we're able to find for the inverse, because of the swappy nature of our domain and range, corresponds to the output at this number. So the matching reciprocal derivative, we have to go to, instead of 2/8, 8/2. I know is not a super satisfying answer. Let's look at this diagram for a little bit. CD, DC, CD, DC. So the first derivative gets us there, the second inverse. Because if we then looked at why does that work? It's always the why. For now, we're going to say because it does. Because it does. So yeah, this is the relationship that you need to glom onto. Okay. Next problem. Number 8. The next one. Number 8. Yes, number 8 will for sure be on your test in some way, shape, or form. This is doing a permanent U-sub. The permanent U-sub. We've kind of talked about in passing. So 8 is asking you to look at a given integral. In this case, x to the e times e to the x squared. And then it gives you 5 answer choices and says, which of these 5 choices is equivalent to this guy? Well, I suppose if you were really desperate, and I don't know how to police this, but these should generally not be calculator problems. But you could theoretically plug this into your calculator and all 5 of your answer choices into your calculator. But that would not be very honest of you. The way we're going to do this is do a U-sub. If we let u equal to x squared, that means that du is twice x dx, which means that dx is equal to 1/2 x over 2 du. So then subbing this in, we end up with 0 over the integral from 0 to 4 of e to the u times x. I'm sorry, this should be du divided by 2x. Du divided by 2x times du divided by 2x. The x's cancel. Oh, happy day. We get 1/2 the integral from 0 to 4 of e to the u du. We pull up our answer choices. And we're like, where's 1/2 the integral from 0 to 4? Oh, what? Was this like a choose all that apply? Because my brain says we should also then do a permanent. Oh. Okay, yeah. So the tempting wrong choice here is A. Okay. A looks like what we just wrote down because it is. However, it is not actually equivalent because of the U. If we just integrated this, there's no, we don't know what the side hustle is. We don't know that U is equal to X squared. So I'll kind of do this on the calculator in a second to illustrate. What we actually need to do here to get to the right answer is do the permanent U-sub, where if u is equal to x squared, then we need to turn these limits into their u versions, meaning plugging in 0 and 4 here. This is 1/2 the integral from 0 to 16 e to the u. And now we could proceed and not ever have to sub back in for u. Okay, and you're probably thinking, oh, what's the difference? Because again, with our, the answer that a lot of us probably wanted was 1/2 0 to 4 e to the u du, which the reason we want that is because that shows up exactly in our problem solving. But we need to realize that in order to actually get to the final answer here, we would continue going with this 1/2 e to the u from 0 to 4, but then u gets subbed back in here. We go 1/2 e to the x squared from 0 to 4. If we didn't do this sub back in, let's go all the way here. We get 1/2 e to the 16 minus e to the 0, or 1/2 e to the 16 minus 1/2. Over here, we would get 1/2 e to the u, evaluate at 16 and 0, without a u sub now, because we did the permanent u sub, which turns into 1/2 e to the 16 minus e to the 0, or 1/2 e to the 16 minus 1/2. So why is this not the correct answer? Because if you're walking down the street and you bump into this integral, you don't know that this has been u subbed. If you just evaluate this as you see it, this becomes this guy. You don't do the u sub back in because you don't know there's a u sub here. You just see e to the u, you do the integral, you plug in 4 and 0. You get 1/2 e to the 4th minus 1/2 e to the 0. This is not the value of our integral. This is not the value of our integral. But that is what answer choice A would lead you to. So definitely a little bit tricky there. But understanding what the permanent u sub looks like. Subbing in our limits into our definition of u. Yeah, that will definitely be on your test. We'll do number 9 and then maybe open it up for general questions. Number 9. What are we looking at for number 9? Yeah, a little complete the square action. Nothing like completing the square on a Tuesday morning. Do it. Okay. Oh, really? That's gross. Let's do it. No, yes, I can't do that. Never mind. Oh, wait, number 9, not number 10. Number 9. Yeah, number 9. Let's do number 9. Do number 10 too if you want. We don't have to. The integral from 0 to 1. of e to the negative 4x dx. Let's do a u sub, because I want e to the u, not e to the negative 4x. U is equal to negative 4x. Sure. Du then is equal to negative 4 dx. Sure, sure. Dx then is equal to negative 1/4 du. Sure, sure, sure. Subbing everything back in, we're going to end up with negative 1/4 times the integral from 0 to 1 of e to the u du. We know how to integrate this because the natural exponential function is its own derivative and its own integral. Like a, what are those weird sea creatures? They're both their own father and mother. I forget what it is. An anemone. That's what the natural log or the natural exponential is. Its own father, its own mother. It's weird. E to the u from 0 to 1. We got to plug back in for u. E to the negative 4x. Evaluate at 0, 1. We just got to be careful here. Negative 1/4 times, plug in a 1 here, we get e to the negative 4 minus, plug in a 0 there, we get e to the 0, which is like 1. So my brain says that turns into like a positive 1/4, like when we distribute this. 1/4 times negative e to the 0 is a positive 1/4. And then we'll just keep this as 1/4 e to the negative 4th. And part of the deal with multiple choice tests is you got to find the answer choice that actually matches what you have. So let's see what options we have. Our option, that's not what I want. We have a e to the negative 4th over 4. Doesn't really look like us. Negative 4 e to the 4th. That doesn't really look like us. E to the negative 4th minus 1. That doesn't really look like us. 1/4 minus, okay, 1/4 minus e to the negative 4 divided by 4. Yeah, that looks like us. They just wrote it as e to the negative 4th over 4 instead of 1/4 times e to the negative 4. Whew. That was number 9. So we've got about 10 or 12 minutes left. Was there another question that maybe didn't get reflected in the survey that we are dying to see? Number 7 was the other one. 7? Yeah, 7 kind of throws you off because we forget that e is just a number. And so 7 is asking us to do the integral of e to the x plus e. Integral of e to the x plus e. That's it. Indefinite integral. Well, we know that we can split sums into separate integrals. E to the x plus the integral, dx, dx. This guy, hopefully we're comfortable with, is just e to the x. The e here throws us off But if this was the integral of 5 dx, what would our integral be? Not 5, but 5x. Okay, the integral of c d to the x, where c is some constant, is equal to c times x plus c. Okay, or c constant. E is a scary looking constant, but it is a constant. And so its integral is simply e times x. And that should hopefully be one of our answer choices. Am I sharing that? Hopefully. E to the x plus e times x plus c. Oh, happy day. Yeah. Definitely feels a little ln and e to the heavy, but the cookie's crumbling. Do we want to see the double u sub? Or do we just want to put our heads down and cry? That'll probably be more useful for your test tomorrow. Yeah, 16.
Not 16,
6. If y equals x squared times e to the x, then dy dx. This feels like a product rule. Let's see. Let's see.
You know, actually, I can do it, and then you just told me product rule. I did new product rules.
Yeah. First function is x squared. Second function is e to the x. Do the product rule. Maybe I'll just show you. Did I do it in here? I sent it to Sheer. Yeah. So we won't do the whole thing. This was number 25 from, I think, 5.8. Yeah. This was number 17 on the year of problems that Mr. Smith couldn't do conservatively. Stop share. Let's do. And it had looked like this at the start. And we're like, yeah, okay. We're gonna like maybe do some U sub. That didn't really yield what we wanted. We're gonna complete the square. That worked a little better. And we ended up with x over the square root of 3 squared minus u squared. And this bit was feeling so inverse sine to us. So inverse sine. But this x was just like not that chill. And so the move here was to actually do another u sub. Are you kidding me? I never kid. Okay. Should we just start this over? No. So was doing the u sub to get rid of the x, which is something that we've seen before. That's still kind of within our wheelhouse. And then splitting this integral into u divided by this guy minus 1 divided by this guy. This guy his inverse sine all day, every day. This guy, we're still sort of looking at like, I don't really know how to do that because we've never done anything like this. You actually have to do a second U sub, or as we call it, a double U sub. You use a second variable, and W is kind of a nice one to use because it's a double U sub, where you're going to make a U sub out of this guy, which then allows you to evaluate this integral, because then it turns into just 1 over the square root of W, and then you can evaluate that. Again, this is not going to be on your test. There's always a possibility it could show up on your AP test, but the double U sub is something we had not seen before, but it's possible. So that was sort of fun. Uh-oh. Blinking red box. Can I do 13? Try. I feel like I'm due for a stumble though. So let's see. New share. No, I'm going to keep this share. I'm not doing a new share. I'm just going to look up number 13. Practice test 13. Kitten weighs 85 grams at birth. I already hate this problem. Why? Can't stand cats. Better than any cat, any dog. Just my opinion, but it's right. A kitten weighs 85 grams at birth. During the first 4 weeks after the kitten's birth, its weight in grams is given by the function W. It satisfies the differential equation dW dt is equal to K times W, where T is measured in days and K is some positive constant. Which of the following could be an expression for W of T? Okay. So this is from 5.3, I believe. 5.3, let's jog our memories. Application of the natural exponential. No, 5.6. Samsonite, I was way off. Okay. And what it tells us is that if we have some quantity whose rate of change is proportional, we went through this whole rigmarole that told us that that means that the quantity itself is going to be governed by this function, this initial quality times E raised to some constant raised to the T. So our problem gives us those parameters that we're going to play with. Specifically, it tells us that the weight of the kitty, or specifically the way that the weight changes with respect to T, is equal to some constant times that weight, which means that our weight is going to be equal to some initial weight times E raised to some constant raised to the T. Cool. So we need to figure out what our initial weight was, 85 grams. This should turn into weight is equal to, so weight is equal to 85 at T equals 0. So weight is equal to 85 E to the KT. I don't see a second condition, so I'm kind of curious. I think we're just finding one that looks like this, because we would need a second condition like, oh, after 10 days, the kitty weighed 100 grams in order to actually figure out what this K was. And since they don't give us that, my hunch is that our answer is just something that looks like this with some random K. And I see answer A is 85 E raised to the 0.059 T, which that to me looks like our answer. when a derivative is directly proportional to the quantity itself, we're going to end up here. We're going to end up here. All right, I think that's all I got for you. We'll take the first half tomorrow and second half on Thursday. If you have questions that come up in the next, let's say 10 hours or so, feel free to email me. After that point, I would probably 11 hours or so, I'll try to get back to you. But in 11 hours, the UCLA basketball game starts, and I'm not going to be doing any schoolwork after that. Okay, have a wonderful rest of your day, and we'll see you tomorrow.
Thank you.
Bye, thank you.
Like a 5-point R assignment this time around.
Nope, your review assignment is the practice test.
I don't think chapter 8 homework is posted yet.
Okay, I can post that today. You're welcome.
Mr. Smith.
They got a test tomorrow. They got questions. What's up, Edgar?
Do you think you could take another look at that recommendation? I know it's due, I think, tomorrow night.
Sorry, the bell is ringing right as you're asking that question.
Do you think you could take another look at that recommendation?
That is getting done during first period today.
Perfect. Thank you so much.
No worries.
All right. Thank you. Have a
Okay.
good one.